there it is.
Hey,
It's all done.
Wow, that's gorgeous. Hey, can you step to the side a little bit? I
sure.
just want to see it better. Yeah, a little bit
Sure.
more.
Here?
Yeah, perfect.
I am freezing!
No, you feel cold. Did you know that cold technically doesn't exist? How so? Come on, I'll explain. When I tossed water on Jeremy, he went from being toasty warm to freezing. Does that mean I added cold energy to Jeremy? No. Well, what exactly does that mean? To explain, let's take a look at two types of measurements: temperature and kinetic energy, or KE. First, temperature. Everything in the world is made up of molecules. Here's an example. 2 cups of water, each made up of molecules. Now, what's the difference between the 2 cups of water? The cup on your left has molecules that are moving slowly, measuring out at a low temperature. The cup to your right has quick-moving molecules, so its temperature is high. We call the measurement of molecular speed temperature.
Okay, so now what does kinetic energy mean? Well, kinetic means movement. So we're talking about moving energy. And that involves 2 things: temperature and mass, or how much of something. So if you remember, Austin talked about temperature, where we had 2 cups of water that had molecules moving at different speeds. Which of these has more energy? The hot one. Because there's more movement in it. But remember, we also have to consider mass. So if we had 2 glasses of water that had different amounts of liquid in them, their temperatures might be the same, meaning that their molecules are moving at the same speed, but one of them has more mass. If we count the number of moving molecules inside each of these cups, what we're going to find is the one with more mass has more energy.
But Jeremy, what does that have to do with cold energy?
Okay, the point here is you cannot add cold. And I've got 2 examples. Suppose you've got water that's at room temperature and have another cup of hot water that you add to it.
Sulking with its slow-moving molecules, a cup of cold water catches sight of something above. A cup of hot water. Molecules racing, hot water greets cold water.
Hello there.
I want more energy. Come on down.
Oh, here I come.
And down hot water dives into cold water's cup. As they mix, cold water's molecules gain speed and temperature.
Okay, so what just happened here? Now remember, the hot water has more kinetic energy, which means that when that energy is being transferred, we have what you call heat. So now this water has been warmed up. So suppose now I were to add ice to it.
Hanging out in its cup, hot water with its speeding molecules sees something above.
There.
What does it see? A cube of ice, sitting all by its slow molecule self.
It's just not fair. I want more energy too.
Come here. Come on.
Ice cube clumps its way out of the cup and cannonballs into hot water's cup.
Oh, boy, here you go. Here
Hot water promptly shares energy with the ice cube. Excited by this, ice cube's molecules speed up, heat up, and he melts into liquid form.
Okay, so does this mean that I've added cold to the water? No, it means that the kinetic energy has been transferred into the ice. Cold cannot be transferred. Hey Austin.
Huh?
If you're underwater, how are you breathing? Later.
That's cold.